All right, let's talk about the unsung hero of your digital life, that little battery inside your phone. I mean, think about it. It's basically a tiny power plant you carry around in your pocket every single day.
So, have you ever actually wondered what's going on inside that thing? You use it every single day? Let's peel back the layers a bit and really dig into the amazing chemistry that keeps you connected to, well, everything.
Okay, so to really get how this all works, we've got to meet the key players first. See, a battery isn't just one single thing. It's more like a team, with a bunch of critical parts all working together in perfect harmony.
The best way to think about it is like a really complex electrochemical sandwich. Seriously, you've got the cathode, that's the positive side, holding all the lithium when the battery is discharged. Then you have the anode, the negative side, which is where that lithium goes to hang out when you're all charged up. The stuff in between, that's the electrolyte, and it's basically a superhighway for all those little ions to travel on. But you can't have the two sides touching, right? That would be a short circuit. So you have the separator, which is like the gatekeeper. And the whole thing is wrapped up in this flexible pouch packaging and controlled by a tiny little brain, the BMS chip, which manages all the safety stuff.
Now, you've probably heard the terms lithium-ion and lithium polymer thrown around, right? Li-ion and LiPo. Well, chemically, they're super similar, but pretty much every modern smartphone you can buy today uses LiPo. And the reason is, well, it's pretty simple actually. It all comes down to that flexible, lightweight pouch design. That's the secret sauce that lets manufacturers make the phones we love so incredibly thin and light.
So we've met all the parts, but how do they actually work together to power your phone? Well, it's not just a one-way street. It's more like this constant, cyclical dance, a flow of power that's always moving back and forth.
And here is that dance in action. When you plug your phone in, you're basically forcing all those little lithium ions to travel from the cathode over to the anode. Think of it like loading up cargo ships at a power dock. You're just storing up all this potential energy. Then, the second you unplug and start scrolling or watching a video, those ions are like, all right, let's go. And they rush back to the cathode, releasing all that energy to power everything you do. This cycle, it happens every single day, thousands and thousands of times over the life of your phone.
But as you can probably guess, doing that dance over and over and over again, it takes a toll. Just like any big power plant, the one in your pocket can't run at 100% capacity forever. It's just inevitable that it starts to wear out.
And I think we've all been there, right? It's so frustrating. The phone that used to last you the entire day suddenly needs to be plugged in by mid-afternoon. But here's the thing. It's not actually a defect. It's just basic chemistry and physics doing their thing. So what are the culprits? Well, a few things. Some of it is stuff we do every day, like using a super fast charger or letting the battery die completely. That puts a lot of stress on it. Heat is another big one. Whether it's from gaming or just leaving your phone in a hot car, heat speeds up the chemical breakdown. But maybe the biggest culprit is something happening on a microscopic level. With every single charge cycle, this thin film, called the SEI layer, starts to build up on the anode. The best way to think of it is like rust. And just like rust, it gets in the way, trapping some of those lithium ions so they can't make the trip anymore. Put it all together, and that's why your battery's total capacity slowly but surely goes down.
Okay, so when you think about all this volatile chemical energy crammed into such a tiny, thin little package, it kind of makes you wonder, right? How on earth do they make these things safe?
Well, the biggest fear is something called thermal runaway. That's the sciencey term for what happens in those super rare but really scary battery fire incidents you see on the news. It's this out-of-control chain reaction where heat just keeps building on itself. And believe me, this is the #1 thing engineers are trying to prevent.
And thankfully, your battery has a whole team of built-in bodyguards to stop that from ever happening. Remember that BMS chip? That's the brain, and it's always monitoring temperature and voltage. If it senses anything's wrong, it can sound the alarm and trigger other protections. You've also got physical safeguards that work kind of like fuses, cutting the power if it gets too hot or if pressure starts to build up inside. It's this whole multi-layered system designed to fail safely, long before there's any actual danger.
You know, for all the amazing advancements in our phones, the battery is still kind of the biggest bottleneck, isn't it? We have these literal supercomputers in our hands, but we're still tethered to a power source that, fundamentally, hasn't changed all that much in decades. But I think a revolution is on its way.
First up, what many people consider the holy grail, solid-state batteries. The big idea here is to get rid of that liquid electrolyte we talked about and replace it with a solid one. Why does that matter? Well, for one, it's not flammable. So you get a battery that's not only more powerful, but also way, way safer. We're talking a total game changer for both performance and peace of mind.
Then you've got graphene. Now just imagine this, charging your phone from 0 to 100% in a few minutes. That's the dream, and that's the potential of graphene. Plus, they would last so much longer, for thousands more charge cycles, which directly fights against that battery aging problem we were just talking about. And here's something really cool. One of these future technologies isn't really future at all. It's already here. I'm talking about silicone anodes. By mixing some silicone into the normal graphite anode, manufacturers can cram in way more lithium ions. And more ions means, you guessed it, more energy and longer battery life. This is a real-world upgrade that's already in some phones today, pushing the limits of how long our devices can last.
So hopefully the next time you look down at your phone and check that battery percentage, you'll see it a little differently. You'll know about the incredible dance of lithium ions happening inside, the silent team of bodyguards keeping you safe, and the really exciting future that's just around the corner. It's honestly one of the most amazing pieces of engineering we use every single day. Which leaves us with the big question, right? Will we ever solve the battery problem for good? And which one of these new technologies will finally be the one to free us all from that dreaded charge anxiety?